Voyager 1 reached the edge of our solar system and found things scientists never expected to see. Even stranger, just after sending some of its biggest discoveries home, the tiny spacecraft suddenly stopped talking. That silence almost ended one of the greatest space missions in history. Before we uncover what Voyager actually found out there, subscribe for more cosmic stories. The story begins long before Voyager reached the edge of the solar system. It starts in the late 1970s, when our planets lined up in a way that happens only about once every 175 years. For a short time, Jupiter, Saturn, Uranus, and Neptune formed a path that a single spacecraft could use like stepping stones. NASA knew this chance would not come again for generations. Missing it meant waiting longer than an average human lifetime. That rare alignment gave engineers one bold idea. Instead of sending separate missions to each giant planet, why not send one spacecraft that could steal a little gravity from every world it passed? Each close flyby would act like a giant slingshot, pushing it farther and faster without carrying extra fuel. It sounded almost impossible. Yet the math said it could work. 2 spacecraft were built for the journey. Voyager 2 launched first in August 1977. Voyager 1 followed just a few weeks later. The names can be confusing because Voyager 1 actually reached Jupiter before its twin, thanks to a faster flight path. That small detail would change history. Nobody expected these machines to become legends. The mission was designed to study Jupiter and Saturn for only a few years. If everything went well, scientists hoped they would send back better pictures, collect useful measurements, and then slowly fade into silence. That alone would have been called a huge success. But space had other plans. Only days after launch, Voyager captured one of its first unforgettable images. Looking back from millions of miles away, it photographed Earth and the Moon together. Our entire home already looked tiny against the darkness. It was a quiet reminder that every city, every mountain, every person who had ever lived shared that small blue world. Then came Jupiter. Scientists expected beautiful pictures. They got much more than that. Voyager discovered faint rings around the giant planet that nobody had seen before. It found new moons. It revealed volcanoes erupting on Io, marking the first active volcano ever observed beyond Earth. Europa looked nothing like researchers imagined, with a frozen surface cracked like broken glass. Those strange lines hinted that a hidden ocean might exist beneath the ice. That single visit completely changed how scientists viewed the outer solar system. Here's where the story gets even more interesting. Many people think those discoveries were Voyager's greatest achievement. They weren't. Everything you've heard so far happened while the spacecraft was still visiting planets, exactly as NASA had planned. The real surprises began only after the cameras stopped taking pictures, after the famous flybys ended, and after Voyager left the last giant planet behind. From that moment on, it was heading somewhere no human machine had ever reached before, carrying questions that nobody on Earth knew how to answer. No spacecraft had ever crossed that frontier before. From that point forward, Voyager was no longer exploring planets. It was exploring the invisible border between our solar system and the rest of the galaxy. Scientists believed they already understood what waited there. The sun constantly throws out a stream of charged particles called the solar wind, and as those particles spread farther into space, researchers expected them to become weaker and weaker, until they simply faded away into interstellar space. It sounded simple. Reality was anything but. Before we go any farther, if you're enjoying stories that reveal the hidden side of space, make sure you subscribe, because some of the greatest discoveries ever made are still happening right now, and you won't want to miss them. Now, back to Voyager. As the spacecraft raced farther from the sun, its instruments kept measuring the invisible environment around it. Year after year, the numbers slowly changed. The solar wind became weaker, just as scientists expected. Everything looked normal. Then, after traveling for more than 3 decades, Voyager reached the very edge of the sun's influence. That's when everything changed. Instead of fading away gradually, the solar wind hit what looked like a wall. On August 25, 2012, Voyager 1 recorded a sudden collapse in charged particles coming from the sun. At almost the exact same time, particles arriving from deep interstellar space suddenly increased. It wasn't a smooth transition. It was a sharp boundary. Scientists were stunned. For decades, many believed there would be a wide mixing zone where the solar system slowly blended into the galaxy beyond. Voyager showed something completely different. The edge of our solar system behaved more like a coastline than an endless beach. One side belonged to the sun. The other belonged to the galaxy itself. And Voyager had crossed it. 6 years later, Voyager 2 reached that same boundary. Instead of confirming every detail, it created even more questions. The second spacecraft crossed the heliopause under completely different conditions, suggesting that the border wasn't fixed at all. It was moving, changing shape, and reacting to forces scientists still didn't fully understand. Here's the part that almost nobody talks about. The heliosphere isn't a perfect bubble surrounding our solar system. Voyager revealed that it stretches, bends, and shifts as powerful forces from interstellar space push against it. Imagine blowing up a balloon underwater. while invisible currents keep squeezing it from different directions. That's much closer to what our solar system actually looks like. But that wasn't the biggest surprise. The instruments kept sending back numbers that simply refused to match decades of scientific models. The farther Voyager looked into interstellar space, the stranger the data became. The next discovery would force scientists to question some of their most trusted ideas about the space between the stars. For years, researchers believed they understood what should happen at the edge of the solar system. As the solar wind slammed into the gas between the stars, computer models predicted a huge buildup of heat and pressure. The numbers looked solid. The physics seemed settled. Voyager disagreed. When its instruments measured the temperature near the heliopause, the readings were nowhere close to what scientists expected. The particles should have been much hotter and much denser. Instead, both values came in nearly 10 times lower than the leading models predicted. Nobody saw that coming. Somehow, a massive amount of energy had simply vanished. It wasn't destroyed because energy doesn't just disappear. It had to be going somewhere else. The problem was that nobody could explain where. That mystery still hasn't been fully solved. Then Voyager uncovered another surprise. Beyond this heliopause, the spacecraft entered interstellar space, a place many people imagine is completely empty. It isn't. Even though the particles are spread incredibly far apart, space between the stars is filled with thin clouds of plasma and powerful magnetic fields. Voyager measured those magnetic fields directly. Scientists expected them to be relatively weak. Instead, they turned out to be nearly 2 to 3 times stronger than predicted. That meant the pressure pushing against our solar system from the outside was far greater than anyone had imagined. Stop and think about that for a second. Our entire solar system isn't drifting through calm, empty space. It's moving through an active galactic environment that's constantly pushing, squeezing, and reshaping the giant bubble surrounding every planet, every asteroid, and every comet orbiting our sun. But the surprises kept growing. Voyager also revealed that particles from the solar wind and particles from interstellar space don't stay neatly separated. They mix together along the boundary, creating a strange transition layer where material from 2 completely different environments interacts in ways scientists are still trying to understand. Even shock waves from the sun don't stop at the edge. Huge bursts created by powerful solar storms can travel across the heliopause and continue deep into interstellar space, proving that the sun's influence reaches much farther than anyone once believed. At the same time, forces from outside the solar system can push back toward us, changing the size and shape of the heliosphere itself. Everything is connected. Here's where the story becomes even more incredible. These discoveries aren't just helping us understand our own solar system. Every star in our galaxy blows out its own stellar wind. Every one of those stars may also have a protective bubble like ours. By studying Voyager, scientists aren't learning about one star. They're building a blueprint for understanding billions of stellar systems scattered across the Milky Way. And just as Voyager was rewriting astronomy textbooks, something happened that almost ended the mission forever. Without warning, the tiny spacecraft, billions of miles from Earth, began sending back data that made absolutely no sense. Mission controllers first noticed that Voyager 1 was still talking to Earth, but its messages looked completely wrong. Instead of reporting where it was pointing or how its systems were working, the spacecraft began sending strange patterns of numbers. Some values stayed frozen, others repeated over and over. Nothing matched the probe's actual condition. It was a mystery unlike anything NASA had faced before. At first, engineers weren't even sure if Voyager itself was damaged. The radio signal was strong. Commands were still reaching the spacecraft. Somehow, the probe was alive, yet the information coming back made almost no sense. It was like calling a friend, hearing them answer the phone, but every sentence they spoke came out as random words. That raised a frightening question. If Voyager could no longer explain what was happening inside its own computer, how could anyone fix a spacecraft sitting more than 15 billion miles away? There was no second chance. Every command sent from Earth needed about 22 and a half hours to reach Voyager. Then the team had to wait another 22 and a half hours for a reply. One simple test could take nearly 2 full days. A single mistake could permanently end one of the longest scientific missions ever attempted. Imagine trying to repair a computer. Now imagine that computer is so far away that every click of the mouse takes almost 2 days to see the result. That's exactly what NASA was facing. Then, on November 14th, 2023, the situation became even worse. Voyager suddenly stopped sending usable science data altogether. Months of silence followed. Many people feared the mission had finally reached its end. After surviving nearly half a century in deep space, after visiting giant planets and becoming the first spacecraft to enter interstellar space, Voyager might finally have gone quiet forever. But the engineers refused to give up. After weeks of investigation, they discovered that damaged code inside the spacecraft's flight data system had corrupted part of its memory. The solution sounded simple on paper, but had never been attempted at such a distance. They decided to move the affected software into unused sections of Voyager's computer memory. asking a machine built in the 1970s to reorganize itself while drifting through interstellar space. It was an extraordinary gamble. On April 18, 2024, NASA transmitted the first repair commands. Then came the hardest part, waiting. Nearly 2 days later, a signal finally returned. The repair had worked. Voyager was talking again. A spacecraft designed for only a few years had survived another crisis, almost 50 years after launch. Even today, it continues sending precious data from a place no human being has ever visited. Yet perhaps the most emotional part of Voyager's story has nothing to do with science at all. It has everything to do with what happens when that final signal eventually disappears forever. Right now, both Voyager spacecraft are still moving away from Earth at incredible speed. Every second, they travel deeper into a place where no human machine has ever gone before. Their radio signals are becoming weaker, their power supply is slowly fading, and every year NASA must decide which instrument to switch off so the others can keep working a little longer. It's a race against time. The electricity keeping Voyager alive doesn't come from solar panels. Sunlight is far too weak at that distance. Instead, each spacecraft depends on a radioisotope power system that naturally loses a little energy every single year. There is no way to recharge it. There is no way to replace it. Once the power is gone, the mission is over. Engineers have already begun shutting down instruments one by one to stretch the remaining energy for as long as possible. Every shutdown is carefully planned. Every decision asks the same painful question. Which experiment is worth losing today so another can survive tomorrow? Think about that for a moment. After traveling for nearly half a century, Voyager isn't failing because it hit an asteroid or suffered a catastrophic explosion. It's simply growing old. Like any machine, it has reached the point where every extra day becomes a victory. But even when the final transmitter goes silent, Voyager's journey won't end. In fact, it will only be getting started. Voyager 1 is expected to spend hundreds of years crossing the inner region of the Oort cloud, the enormous shell of icy objects that surrounds our solar system. Crossing the entire cloud could take tens of thousands of years. Only after that incredible journey will it truly leave the sun's gravitational neighborhood behind. Voyager 2 is following a different path through the galaxy, carrying the same message into the unknown. And speaking of messages, hidden inside both spacecraft is one of the most remarkable objects humanity has ever built. It's called the Golden Record. Instead of scientific measurements, it carries sounds, music, greetings, photographs, and pieces of life from Earth. There are voices speaking dozens of languages, songs from different cultures, the sound of waves crashing onto a beach, birds singing at sunrise, a baby's cry, and even greetings recorded for anyone who might one day discover the spacecraft. Will anyone ever find it? Nobody knows. Maybe the Golden Record will drift through the Milky Way forever without another civilization ever seeing it. Or maybe millions of years from now someone or something will finally press play. That possibility is enough to make Voyager more than a spacecraft. It has become humanity's message in a bottle, floating across a cosmic ocean far larger than we can truly imagine. And when you step back and look at the entire journey, one realization becomes impossible to ignore. The greatest achievement of Voyager wasn't reaching the edge of the solar system. It was proving that a small machine built almost 50 years ago could forever change the way we understand our place in the universe. It has become humanity's message in a bottle, floating across a cosmic ocean far larger than we can truly imagine. But here's something that surprises almost everyone. Despite headlines saying Voyager has left the solar system, that isn't completely true. It has crossed the heliopause, the point where the sun's solar wind gives way to interstellar space. Yet the sun's gravity stretches much farther than that, reaching into a vast region known as the Oort cloud. That means Voyager is still traveling through territory that belongs to our solar system, and it has an unbelievably long journey ahead. Scientists believe the inner edge of the Oort cloud is still hundreds of years away for Voyager 1. Crossing the entire cloud could take around 30,000 years. Only then will the spacecraft finally leave the sun's gravitational influence behind. Stop and picture that. Everything humanity has ever built, every country, every language, every war, every invention, every dream has happened during only a tiny fraction of the time Voyager still needs to finish leaving our own cosmic neighborhood. The numbers are almost impossible to imagine. Voyager 1 is moving through space at thousands of miles every hour, yet the universe is so enormous that even after nearly 50 years of non-stop travel, it has only completed the first chapter of its journey. And that's exactly what makes this mission so extraordinary. The spacecraft wasn't built for this. Engineers expected it to work for only a few years. Instead, it has continued exploring for decades, surviving freezing temperatures, intense radiation, computer failures, and distances so great that every conversation with Earth takes almost 2 full days. Very few machines in history have ever exceeded expectations like this. Even more remarkable, Voyager is still teaching us new things. Every bit of information arriving from interstellar space helps scientists improve models of how stars interact with the galaxy around them. The data isn't only about our sun anymore. It helps researchers understand how countless other stellar systems may protect their own planets from dangerous cosmic radiation. In other words, Voyager has become a guidebook for worlds we've never even visited. That's an incredible legacy. But there's one final reason this mission continues to capture people's imagination after nearly half a century. It isn't because of the technology, it isn't because of the distance. It's because Voyager reminds us what happens when human curiosity refuses to stop. A spacecraft built before the internet, before smartphones, and before most people had home computers is still expanding the boundaries of science today. Every faint signal reaching Earth proves that exploration doesn't always require bigger machines. Sometimes it only requires the courage to keep going farther than anyone ever has before. And when the last signal finally fades into silence, Voyager won't really be gone. It will continue sailing through the Milky Way for millions of years, carrying the only message our civilization has ever sent beyond the edge of the known, long after every person alive today has become part of history. That may be the most astonishing discovery of all. When most people think about Voyager, they picture a lonely spacecraft disappearing into endless darkness. But that's only part of the story. The real achievement isn't how far it has traveled. It's what that journey has taught us about ourselves. Every major discovery Voyager made began with a simple question. What is Jupiter really like? What hides beneath Europa's frozen surface? Where does our solar system actually end? Each answer led to an even bigger mystery, proving that the universe is far stranger than anyone expected. That's how science moves forward. Not by proving we already know everything, but by showing us how much remains unexplained. Think about everything Voyager changed. It revealed active volcanoes on another world. It helped spark the search for hidden oceans beyond Earth. It transformed Uranus and Neptune from blurry dots into real places with unique weather, strange magnetic fields, and entirely new types of planetary systems. Then it became the first human object to cross into interstellar space and discovered that the boundary protecting our solar system behaves nothing like scientists had predicted. One mission. Dozens of discoveries, countless new questions. And perhaps that's Voyager's greatest gift. Instead of giving humanity all the answers, it gave us better questions to ask. Today, every new mission heading toward the outer planets builds on what Voyager first discovered. Spacecraft like Europa Clipper, future missions to Uranus, and even plans for interstellar probes exist because two machines launched in 1977 proved that impossible journeys could become reality. Voyager showed us the path. Now others will follow. One day, a new spacecraft may travel 10 times farther. Another might finally photograph the solar system from deep interstellar space. Someday, humanity may even send people beyond the planets Voyager left behind decades ago. Every one of those dreams traces back to this mission. A pair of spacecraft built with less computing power than a modern calculator somehow outlived generations of technology, survived failures nobody expected, and continued making discoveries nearly 50 years after launch. That isn't just an engineering success. It's a reminder that curiosity can outlast the people who first imagined it. Long after the voices inside NASA's control rooms have gone quiet, long after the engineers who built Voyager have become part of history, the spacecraft will still be moving forward. It won't know that civilizations changed. It won't know that centuries passed. It will simply continue its silent journey through the Milky Way, carrying a small golden record and the hopes of an entire planet. Maybe no one will ever find it. Maybe someone will. Either way, Voyager has already accomplished something remarkable. It proved that humanity's greatest discoveries don't always happen when we reach our destination. Sometimes they happen because we're willing to keep exploring long after everyone else thinks the journey is over. And that's a lesson that reaches far beyond the edge of the solar system. The universe has a strange way of changing our perspective. When Voyager lifted off in 1977, nobody knew if it would even